In this video, we're going to introduce the concepts of the maximum and minimum values of a function. So let's consider a function y equals f of x, whose graph is shown here. And you can see that the graph is defined on a closed interval from a to b, because you have the closed circles on either endpoint. We'll indicate that in interval notation, the graph is defined on a closed interval from a to b. And remember, the square brackets mean we're including the endpoints a and b. And we're interested in finding the absolute maximum value of this function. All we mean by the absolute max value of the function is we're looking for the greatest y value, the greatest y value of function f. And so we notice that the maximum occurs, the absolute max occurs here at the highest point of the curve. That's our absolute maximum. It occurs at the point b comma f of b. But if we wanted to know what the absolute maximum value is, what's the value of the absolute max? That's just the y-coordinate of the point, or f of b. So the absolute max value is just this y-coordinate of the location of the point f of x. Okay, now, taking a look at the absolute minimum value, intuitively, that's a similar kind of thing. It's just the lowest or the least point, the least y value, the least y value of the function. And so we have, it occurs at the point x equals a and y equals f of a. So that's where your absolute min occurs. And the absolute min value is simply the y-coordinate of that point, f of a. Okay, now we'll turn our attention to the local max and the local min. And in order to do that, it helps if you notice that there's a round hill at one point, we'll call that C, and there is a round valley, if you will, at D. And this round hill has a property, first of all, that it's smooth, and it's also got the property that the tangent line at that curve, I'll do my best to draw a straight line, is horizontal. So the tangent line at this curve is horizontal. And if you remember, the tangent line has slope equal to 0. And that's what happens when you're at a rounded hump or a rounded valley. And here we'll say, again, doing my best to draw a straight line. Use our imaginations. But it also has a horizontal tangent line, where the tangent line has a slope equal to 0. And you might remember that the slope of a tangent line can be found using the first derivative. And if we're saying this tangent line has a slope of 0, we're saying the first derivative is equal to 0. So when we have a horizontal tangent line, we're saying the slope of that tangent line is 0 because it's a flat line and it's horizontal, and the slope of any horizontal line is 0. But we also remember that the first derivative gives us the slope of the tangent in general, and if it's equal to 0 because it's horizontal, this gives us very important information about how to find this local max and local min. Okay, so here At the top of the hill is where we have a local max. And here at the bottom is where we have a local min. The reason it's called a local max is because essentially, well, first of all, it's a smooth hill. It's at the top of a smooth hill. It's a local max, and it has the greatest y value of f, and here's the key part, near c, near the value of x equals c. So near c, if you go out just a little bit on either way, this will be the highest point, and it's called the local max. And a key property, the way we're going to find this, and we'll show this in the next video, the way we find the actual local max and local min is we're going to find the first derivative, set it equal to 0, and solve for x, and that's where the local max and local min occur. Now, just to finish off our talk, the local min is going to be the least y value, of f near c. And again, it has the property that f prime of f equals 0. And so we have, let's just summarize what we've done here. The absolute minimum value is the smallest value, or the least y value, of the function over the entire domain. The absolute max value of the function is the greatest y value of the function over its entire domain. Now remember, the domain here is just the interval from a to b. The local max is the greatest y value of f near a specific point. We'll call it d, or c rather, c. And over here, our local min, I almost made a mistake there. The local min occurs near d, and we say it's the least y value of f near d. And both the local max and local min occur where the first derivative equals 0.